I'm still primarily motivated by the environmental angle. We need space. We need space to understand the Earth in the near term. I want to be very clear. I am not one of those crazy people who thinks that we know enough to start engaging in geoengineering. That is a perspective based on profound ignorance of our level of knowledge. We're way short of being able to manipulate the environment on a global scale. We'll eventually get there, but we're not even close to that level. But we will get to that point. And when we are to that point, we will need the resources of space in order to be able to do that. It's simply inconceivable that you can do that from inside Earth's biosphere. The analogy I like to use is fish farmers. So the analogy I use as a fish farmer is because you imagine, could you manage a fish pond from inside the pond without the ability to take things in, take things out, and observe it from the outside? And the answer is, well, maybe you could, but it'd be really hard. Whereas managing a fish pond as a fish farmer on the outside, you can add fertilizer, aerate the water, and so you can add oxygen, manage the environment effectively. You can manage a fish farm environment, right to the edge. I mean, you can really do a great job and create a wonderful environment for the fish to grow big and fat and tasty. And I think ultimately we can manage Earth's environment. In the meantime, we need space to learn about the environment. It's very difficult to study Earth on a global scale from here. Most of our information, or large-scale ecological information, comes from space. And that's not because, as some people think, that it's this boondoggle, and we do it because it's the only way we can gather that data. It's very difficult to gather this data when you're wading through the forest. It's much easier when you're above the forest, looking down at it and making global measurements. Now, you need to go on the ground and confirm it. It's not like you can do it all from space, but it's a critical element, and it's a very underfunded element of our global space effort. I'm pleased to say the United States actually funds it reasonably well, but around the world it's dramatically underfunded, and we need to spend a lot more on studying the Earth and trying to understand what it is we're doing to the Earth, so that we don't screw it up worse than we already are. We also know remarkably little about the atmosphere. The suborbital vehicles that are under development create a wonderful opportunity to study what some are calling the ignorosphere. We actually know a fair amount about the atmosphere down here and up to the level where weather balloons go, 100 and a few thousand feet. Because we send up weather balloons, we have instrumentation on them, we've been studying this for years, and we've sort of figured that out. I mean, there's still more to know, but we've made a lot of progress there. And in recent years, we've gotten a great deal of information from the International Space Station, which I don't know if everyone understands that it flies in the atmosphere. There's a fair amount of atmosphere at the level of the ISS. It's why it has to be constantly reboosted, because there's enough drag there to pull it down, and the big cost of the ISS, the single largest cost, is bringing fuel up to keep it boosting, so that it can stay in that upper atmosphere. If you stop boosting it, it will fall down. And we've, particularly since the Japanese modules up there, there's a number of very good experiments on what they call the back porch of the Japanese module, which is sort of a funny thing to call it. It's not like you have to be out there laying out in the sun, right? But it's a little experimental pallet on the outside of the Japanese module with its own robotic arm and the ability to do experiments there. And they've done a lot of atmospheric work. But we know almost nothing about the atmosphere between the level of the balloons and the level of the ISS. And it happens to be that that's the zone in which all these suborbital vehicles are going to be flying. Up till now, our only access to that area were sounding rockets, which are expensive, fly very rarely, and it gives you very limited access. Well, these guys plan to be flying in that zone several times a day. And atmospheric scientists are pretty excited by the opportunity to put experiments on these vehicles and get decent sampling and start understanding what's going on in that part of the atmosphere. Pretty much the only thing we know about that part of the atmosphere is that it's interesting and important. Beyond that, we don't know much. And so that's really going to be very exciting over the next few years as we begin to piece that together. One of the things that amuses me is the debate over global warming. It's two sides immersed in ignorance, saying, "Oh, we know what's happening. Humans are not affecting the globe, or they have great ideology." But you talk to the atmospheric scientists, and they go, "I mean, we'd like to know." We think maybe some really bad things are happening. The odds don't look good, but they talk in the terms that scientists talk. They talk in terms of probabilities, in terms of uncertainty. But whether you listen to Al Gore, or whether you listen to some climate change denier, they talk in the language of certainty. And to me, the most important thing to know is to get rid of some of that uncertainty and to know to narrow the range of uncertainty and get a sense of what's going on and what is likely to really happen. And an atmospheric science offers the opportunity to do some of that. And so I'm really up for it. I think it's great stuff.